today's lesson, we are going to be looking at factorials and permutations. So this is going to build off the previous lesson where we looked at the counting method, or the fundamental counting principle, and it's going to incorporate it into again, more specific scenarios. So let's review. On selecting patio stones, the customer has 10 choices for the type of brick, 8 choices of color, and 3 choices of layout. How many different patios are possible? So you can use a tree diagram and the counting principle. Again, this one I'm not going to pause the videos because these are relatively quick. I will let you try the tree diagram on your own. But in terms of the counting principle, in terms of colors, we have 8 possible colors multiplied by 3 choices of layouts, giving us 24 different patios. 24 different patios. A team has 23 members on it. How many ways can a captain and assistant be selected? Well, in this case, looking at the captain and the assistant captain, we have 23 possible players to be picked for the first one, multiplied by 22 for the assistant, because assuming that the captain is picked, they also can't be the co-captain or the assistant. So there's 506 ways. How many ways can a captain, co-captain, and water person be chosen? Well, captain for the first outcome or first event, multiplied by co-captain or assistant, multiplied by water person, 23 people multiplied by 22, multiplied by 21. Again, assuming that those people cannot be selected again in having a different role. So we get 10,626 ways. So that's the fundamental counting principle, and then we're going to build off of that. So again, how many ways can you arrange the letters of the word factor? Again, we kind of went through this. Factor, we have 6 letters. So we have 6 spots. At the beginning. And then we have 6 letters for the first option, 5 letters for the second. 4, 3, 2, 1. That's how many different options we have. So we have 720 outcomes, or we could say arrangements. Just different terminology. How many ways can you arrange the letters of the word uncopyrightable? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 letters. Now I could go through and do every single slot, right? I could also use some of my previous knowledge and know that I am doing 15 times 14 times 13 times 12 times all the way down till I get to 1. We can enter this into our calculator as well. And we would get 1.308 times 10 to the power of 12. So quite a large number of ways that we can arrange this letter or these 15 letters. Now, this can be quite tedious, right? If we had to figure this out every time, this is only 15 letters. What if I had more options, right? What if I had to arrange those 23 players from the previous question in a line? 23 times 22 times 21 times 20, so on and so on and so on. There has to be a faster way to do this, and there is. And that's what we're going to learn about today. So the faster way, factorials. So factorials are basically a way to kind of simplify that counting that we just did. Because many counting and probability calculations involve the product of a series of consecutive integers, or basically multiplying numbers that are one after another. So factorial notation is used to write such expressions. A factorial, by definition, multiplies a number given by every whole number below it all the way to 1. So n exclamation mark is read as n factorial and is defined as n times n minus 1, or the number below it, times n minus 2, the number below that, times n minus 3, the number before that, all the way so on until we get down to times 2 times 1. So it works all the way down to times 2 times 1 at the end. That's n factorial. So let's look through and evaluate some of these expressions. We'll look at them looking in the long way. So 5 factorial, or 5 exclamation mark, but again we read it as factorial. Or you can just scream 5 really loud. So 5 factorial is the same thing as saying 5 times 4 times 3 times 2 times 1. On your calculator, you should be able to find an exclamation button, or maybe it is an X with an exclamation. Those are your factorial notations. We end up with 120. 11 factorial divided by 7 factorial. Now you could use your calculator and you would get an answer, I'll put it over here, of 7,920. I'm going to show you a different way to calculate it just because we want to be careful or know different ways. Just because depending on the answer, or depending on the factorial, our calculator may not even be able to calculate it at all. So 11 factorial, we'll do a long way. 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Only have almost got it there. Let's move this down a bit. Off to the end. So that's all divided by 7 times 5, or not 5, 7 times 6 times 5 times 4 times 3 times 2 times 1. Is there any way I can simplify that? Well, there is, because if I'm dividing and by the same numbers that I have on top that I'm multiplying by, they can cancel out. Consistent, so I can cancel out a 7 and a 7, a 6 and a 6, a 5 and a 5, and so on and so on and so on and so on, until it's all that's left is 11 times 10 times 9, times 8, perfect room, which equals 7,920. So again, you could use your calculator to do 11 factorial divided by 7 factorial, or you could simplify it and do 11 times 10 times 9 times 8 and get the answer. And the reason I'm showing you that way is because try to do the next one. 24 factorial divided by 21 factorial. You may be able to get it on your calculator. Some calculators, if you try to do 21 factorial on its own, your calculator may not be able to do it. Or if you had a very large factorial, if you did 50 factorial, you might be able to get it. Well, let's try 100. I'm just using my calculator here. So it can't do 100 factorial. So depending on the numbers or whatever the factorials are, it may be too large. So it does help to know the quicker way. So if I have 24 times 23 times 22 times 21 times 20 all the way down times 2 times 1, divided by 21 times 20 times 19 times so on, all the way down to times 2 times 1. How can I simplify this? Well, I could take everything from 20 to 1, and that cancels out 20 to 1 on top. So this leaves me with 24 times 23 times 22, which is much more manageable on a calculator. 12144. Now again, depending on your calculator, you may be able to just enter it as is. You may not be able to, in which case you would have to kind of use the factorial notation, or the expanded form, you could say, to simplify it to get your answer. Because your calculator can do the 24 times 23 times 22. The other values, depending on how large they are, maybe not. 13 factorial divided by 8 factorial times 5 factorial. So 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 multiplied by the next factorial, 5 times 4 times 3 times 2 times 1. Now again, your calculator may be able to calculate this. I'm just showing you different methods or just how to simplify some of these questions, just in case for whatever reason you're given values that your calculator cannot solve. So what can we cancel out? What can we simplify? Well, I can take out everything from 8 and below with the first 8 factorial. So I'm left with 13 times 12 times 11 times 10 times 9 divided by 5 times 4 times 3 times 2 times 1. Is there anything else I can cancel out? Well, 5 times 2 is 10, so I can cancel out 5 times 2 and 10 on the top. 4 times 3 is 12, so I can cancel out the 12. 1, when I'm dividing by 1, doesn't really matter, so let's get rid of that. So all that's left is 13 times 11 times 9. So 13 times 11 times 9 is 1,287. So again, just different ways to solve these kind of factorial notation problems, simplifying it in a way to make it a little bit easier, kind of reducing it down to what we really need to multiply. Again, depending on your calculator, you should be able to calculate this anyways by just entering it directly. One thing to note that we didn't kind of really bring up, if you ever see 0 factorial is defined as 1. And the reason is because mathematicians said so, right? Because if you had 0 factorial as multiplied by 0, that means it would need to be included at the end of every one of these statements. But what happens when you multiply by 0? It equals 0. So if 0 factorial equals 0, then in every one of these situations, the number of ways would be 0, or the answer would be 0, which doesn't quite work, or it's not very useful. So they've kind of gone through and made the general statement, 0 factorial equals 1. That's what we're keeping it as that. It needs to be that in order for factorials to work. So kind of a cool fact, chances are that with every shuffle of a deck, the order is one that has not existed before in history. If you think about it, well, how many cards are there? There are 52 cards, which means there are 52 factorial ways to arrange them. So 52 factorial is 8.066 times 10 to the power of 67. So that is how many ways there are to order a deck of cards. So chances are, everything being equally random, chances are that the order, when shuffled, is one that hasn't existed before in history, which is quite interesting, but it also shows just how many possible ways there are to do something. Now, permutations are a scenario or a concept that uses factorials. And permutations are defined as the number of ways to order a set of objects from a larger set. Right? An arrangement of items appearing in a set order is also a specific definition. And if we recall the password lock from the last lesson, we would say 26 pick 5, right? Or write it as 26p5 because we have 26 letters and we're picking 5 of them, right? So that was the 26 times 25 times 24 times 23 times 22 times 21. Right? So that is the same thing. Now on your calculator, you should have a button that says NPR on it. That is the permutation button. By pressing that, that will give you the P. So if I wanted to do 26 pick 5, essentially I would do 26 on the calculator. So that's the 26 obviously individually 2 and a 6, plus the NPR button, which would put in the P, plus 5. And it would look like 26P5. And that would give us our answer of 7893600. And this is assuming no repetitions. So factorials and permutations assume that there's no repetitions because it goes through, again, factorials is the one number multiplied by the number after it, multiplied by the number after it, and so on and so on and so on, which essentially means there are no repeats, repetitions allowed. So let's look at an example. How many permutations of 4 students sitting in a row are possible? Well, 4 students sitting in a row, we could think as the 4 slots. I have 4 students. How many ways can they be sitting in the first one? Well, there's 4, then there's 3, then there's 2, then there's 1. Or you could say 4 factorial, or 24 ways. How many permutations of the word virus? So if I wanted to rearrange the letters in the word virus, right? So there are 5 letters. So again, I could think of 5 different spots. 5 letters for the first one multiplied by 4, by 3, by 2, by 1, or just 5 factorial, which is 120 ways. So there's 120 ways that I can rearrange the letters, the 5 letters of the word virus. Now, that was rearranging all of them. Now, in some cases, we may not want to rearrange all objects. We only want to arrange some of them. Again, similar to that law question. So in this case, if we're doing all objects, P, N, comma, N, which is just another notation way to write NPN, which is just the same as saying N factorial, which we just kind of saw in the last 2 examples. Now, if we're arranging some objects, P, NR, or N pick R, that's a little bit different. Now, obviously, this part you can just do on a calculator. This part here is our factorial notation. So if we were using factorial notation, it's N factorial over N minus R factorial. So just 2 different ways to do it. One is if you're kind of doing the actual calculation. The other one is if you're just using your calculator. Again, you can just use your calculator for these types of questions, unless it specifically says it wants it expressed in factorial notation. But if not, you don't have to worry about it. You can just use the NPR. So let's look at this example. So Mr. Liu is going to give an award to his top 3 students. Since all of his students are great, he's going to randomly give them out. How many ways can he select first, second, and third place from 24 students? So in this case, you could do it one of 2 ways. We'll do it the easiest way, which is I have 24 students, and I want to pick 3 of them. So 24, pick 3, that we can just do on our calculator. That is equal to 12,144 ways. You could also think of it as 24 times 23 times 22. I have 3 spots. First, second, third. Randomly select 24 ways for the first one, then 23 because they can't get picked again, then 22 for the third option. The last way is if I have 24 and I'm picking 3 of them and I don't want to use the NPR for whatever reason, 24 factorial over 24 minus 3 factorial, 24 factorial over 21 factorial, which, as we saw previously, works out to 24 times 23 times 22, right? We could expand it doing it the long way, cancel out values or repeats that we have on both the top and the bottom, and we end up with 24 times 23 times 22, which is 121 or 12,144 ways. So 3 different ways that you could go through and solve these types of questions. Again, unless it specifically asks for factorial notation, I would say don't worry about doing the last one. You could choose to do either the NPR or the slot method. The slot method is good for visualizing it. If you have trouble thinking about what's happening, right, put down the different events. Figure out how many options do you have for the first, how many do you have for the second, how many do you have for the third in this case. Solve each of the following using the permutation formula. So this is one where we would have to show the different methods or the full factorial notation. So 8 factorial over 8 minus 5 in brackets factorial. We get 8 factorial over 3 factorial. Now again, you could go through and write it all out. In this case, I'm not going to worry about that because these values are easily done on the calculator. So 6,720 possible ways or arrangements of whatever we're looking at. 5p5, so 5 factorial over 5 minus 5 in brackets, then factorial. So we get 5 factorial over 0 factorial. We know it is 0 factorial is equal to 1, so this is the same thing as saying 5 factorial or 120 arrangements of whatever, of 5 objects. You have 26 Scrabble tiles, A to Z. How many 5-letter words are possible? Well, in this case, I have 26, picking 5. I could do the slot method, 1, 2, 3, 4, 5. Either method works. 26, P5, 7, 8, 9, 3, 6, 0, 0. 26 times 25 times 24 times 23 times 22. Same thing. How many 5-letter words that begin with A? Now this is a little bit different. This one, it does help to use the slot method because if the first one has to be A, there's only one A that we could pick from. So then we have our second letter, which doesn't matter, our third letter, which doesn't matter, our fourth, and our fifth. So the A gets picked in the beginning. So that means there are 25 options, then 24, 23, 22. So you could look at this as in a different light of saying 1 times 25p4, or just 25p4, which is 303600. So 303,600 possible words. Or words in quotations because they may not be actual words, but in this case, arrangements. When asked you to go through and figure out what of those arrangements which are possible words. Right? And again, this is kind of going back to that counting method. We don't care what the individual outcomes are. We just want to know how many ways could it be done. There are 10 math books on a shelf. 3 of them are math, or 10 textbooks on a shelf. 3 of them are math textbooks. And how many different orders can they be arranged? Well, if I have 10 of them, I'm putting all 10 different textbooks. I could say 10p10, or just 10 factorial, or 10 times 10 times 10 times, or sorry, 10 times 9 times 8 times 7 times 6, and so on. 3628800. So 3,628,800 different orders. How many ways can we arrange 4 of the textbooks? Well, I have 10 textbooks, and I'm picking 4 of them. So 10p4. 5,040 ways. Or you could think of it as first book, second book, third book, fourth book, 10, 9, 8, 7, and still get the same thing. So again, different ways you can think of it depending on how you best visualize the scenario. How many ways can we arrange them if the three math textbooks must stay together? So this is a common type of question that you might come across, and there's different things you have to think of. So, and it does help to visualize by using the slot method. So, if I have three math textbooks, right? So we have Math 1, these are our math textbooks, we're going to put them here. So we have 3 times 2 times 1, or in other words, we have 3 factorial ways that we can arrange just the 3 math textbooks. But we also have to think about, well, I have how many other textbooks? Well, there's 7, and 6, 5, 4, 3, 2, 1 options. So this is 3 factorial and then the 7 factorial. So that might be what a lot of people think about. 3 factorial times 7 factorial for the remaining part. However, what you have to think about is that this group of 3 can actually move throughout the different locations. Right? This group of 3 could be somewhere in the middle. They could be after the first textbook. So you have to think of this group so you could think of it joined or together items. Right? So anytime a question talks about they're joined, they have to be together, they're side by side, things like that. You have to. They're grouped. They're grouped as one item. So we have to think of this group as one of the items that we can arrange throughout. So this now actually becomes, I have 8 objects. I have this group of 3, and then the 7 other textbooks that I would have to arrange. So this actually works out to 8 factorial so 8 total items. Say 7 books plus 1 group. So I have 8 total items to arrange, but then I'm multiplying it by 3 factorial, which is the, oops, I'm going to sort this out. The 8 factorial refers to ways to arrange group of 3. So the ways to arrange the items within that group. So 8 factorial times 3 factorial gives me 241,920. So that is how many ways, I'm just going to move this all down a bit, that I can arrange these textbooks if the 3 math books have to stay together. You can think about how that question would change, or how a follow-up question would ask if the 3 textbooks were not together. In how many ways can we arrange them if the 3 math books must stay together, but must be the first group of books you see when looking at the arrangement from left to right? Well, in this case, this kind of goes back to what we originally thought. So we have our 3 math textbooks. I'm going to consider them one giant large item. And within that item, I have 3 times 2 times 1 for how I can arrange those 3 items. Oops. And they have to be at the beginning. So there's no rearranging this group. Actually, let me move it down a bit. So there's no arranging this group. They're at the front. They're not going anywhere. So then that leaves my 7 books after. 6 times 5 times 4 times 3 times 2 times 1. So now we have 3 factorial times 7 factorial, or 30,240. So that's the difference between the two. The one D is assuming that the group has to be in only one spot. In this case, they are. They're at the front when we look at them left to right. Within that group, again, there's 3 different arrangements, or 3 factorial arrangements, of how I can arrange those 3 books. And then C looks at if that group of 3 can be placed anywhere in that order. Right? So because they can be placed anywhere in that order, there's an additional where we consider that another item. So there's the 7 individual items plus that group of 3 makes it 8 total items that we have to arrange. And then we have to, again, consider the arrangement within that group as well. So that's where it gets a little tricky. Right? So sometimes visualizing it does help. The factorials and the permutations, just a fancy way of what we've been doing already. It just helps in the terms of the calculations so that we don't have to enter on our calculator 7 times 6 times 5 and so on. We can just use 7 factorial. So some homework questions. So again, I do really recommend going through these types of questions because again, the concept is relatively straightforward. You're multiplying numbers. It gets difficult when you read the question and have to figure out how you're arranging them or what you're grouping together or what the restrictions are, because that changes. That changes from question to question. So it's really important that you do try the homework and practice it to see those different types of questions, the different wording that you may come across.